G'day and welcome back to Commsverse. As you probably know, this is a session into direct routing. Yes, I do say routing. I'm Australian. I'm weird. We've got Martin over here as our moderator today. Unfortunately, Mark couldn't make it, but we've got a lot to jump into today, and I've got 30 slides and only 30 minutes to do it. So we're going to get really technical, but a little bit of housekeeping first, and I'll let we'll switch over to content and go from there. All right, cool. So just a quick one. We're obviously we're doing an online community conference, and we do have a set of standards and rules. Long and short of it is we're safe and inclusive. We're all adults, and that this is a tech conference. We expect good behaviour from everybody. That includes in these sessions and in the breakouts. So if you could all play along nicely. If you're really interested, there's a full list of set of rules down below. But I think we're all adults here, and we can move on. So a big thank you to our sponsors. I was literally just having a chat with Martin. The team has been working really hard to make this event happen, and it wouldn't happen without our sponsors. This event in period has gone through a lot of change with everything that's going on in the world. So thanks to all the sponsors for sticking around or helping out. So we're talking about direct routing. Now, direct routing, as you probably heard and hopefully have had a little bit of background on, is a service to connect teams into the public switch telephone network. And with direct routing, there may be a real desire to know, to think that you need to be a phone guy or a tech guru. I mean, you look at the wall behind me, which you can't see anymore. I've got phones and I've been working with phones for ages, but that's not true. I actually started out in the industry as a Windows admin. And then I moved into data cabling because I feel like I wanted to do something silly. Started in networking, went and got my networking certifications, firewalls, and then about 10 years ago got into unified comms. So it's not one of these things that you've got to be a phone guy from the start to fully understand, and it's very easy to pick up. So what is direct route? Direct route uses a bunch of different technologies that we need to have a good understanding of to effectively set it up and troubleshoot any sort of direct route session. Now, anyone who's been around in the telephony world for any period of time will know most of these terms, but if not, we're going to break into them and just go to what they are. So for any standard VoIP package, whether it be Skype for Business, Asterisk, FreeSwitch, any of those sorts of things, they've always used SIP. Cisco uses its own protocol, but we won't get into that. And SIP, along with RTP and SBCs. Now, these are things we'll all break down in this session, and hopefully we'll come out with a better understanding of what it is. Things that are specific to Teams, however, are voice routing policies, PSTN usages, and voice routes. And again, that's something we'll get into a little bit later in this session. So let's start with the first item on the list, SIP. SIP is a way of two endpoints communicating together and establishing a phone call. Now, this screenshot on screen right now might look a little daunting and confusing, but we'll break it down very easily. SIP is a way that one phone over on the left here can communicate with a phone on the right and say that they want to set up a phone call. I'm trying to call a particular number, and how the sound or the media, in this case, is going to flow between those two endpoints. So let's get rid of that SIP ladder, and we'll put in two imaginary horses. You can see here that the person on the left is trying to call the person on the right. So what they'll do is they'll send a SIP invite. Hi, I'd like to call you. Here's my information. In that invite, there is a thing called an SDP, which is the Session Description Protocol. And we'll break that down a little bit more later. The remote device, the phone in this case, should respond with trying. Now, typically this is going to be the phone, the PABX, something. Yes, I've got your request. I'm just checking it, and I'm going to checking it out, and I'll let you know how I go. If the phone call gets to the end device, so say, for example, the left phone has successfully reached the right phone will respond with a 180 ringing SIP packet. That means that the device has been found, the user's signed on, you know, whatever, whether it be a phone or a mobile phone device or a soft client, that device is there and it's signed on, and I'm now playing a ringing tone. So in this case, your Teams client would be popping a notification saying there's an inbound call. One of the things that Skype for Business and Teams will do as part of this process to speed things up is it'll also respond shortly after ringing with session progress. This is called early media or early 183. This is done by the remote endpoint to send across its SDP earlier than it should. This just lets us set up the sound channel between the two devices, because keep in mind at this point, SIP is just the communication to set up this phone call. We haven't actually got the sound going through yet. We use these two SDPs to show where that sound's going to go through. And as I said, we'll come to that a little bit more later. Now, the initiating device or the calling device will then respond with a provisional ACK. Yes, I've got your information. It's acceptable. I'm going to open up the sound channel. And we open up that sound channel using the information that is in those SDP sections of those SIP packets. Eventually, the user picks up the phone. Hello, who's there? And the remote device will send back a OK message to the initiator. That OK message contains the SDP if it hasn't already been included. And that is the point that the phones will establish audio communication between each other. Now, it is important, I sort of didn't really say before, but I'll touch on now. 183 can also be used to play early messages, things like ringtones or things like your call is being diverted, please wait. Those sort of informational messages before a call is connected. Those can come through in 183s as well. So it's important to support those and that your SBC supports those. But moving on, we've got our 200 OK. So I acknowledge that I've got the OK and your SDP looks good. We then have the phone call, like we call each other and I'd say, you know, what's the weather like? And we have our conversation. Once I've finished having the conversation, I hang up the phone. So the phone on the left hangs up. So that phone will then send a bye packet. And in that bye packet, it will contain all the information about why that call was terminated, whether the user hung up the phone or a network issue occurred, or in some cases, something went wrong on the user's computer. And the call-e device, the person that receives the call, will then say, yep, okay, I've got that bye. I've terminated the call and I'm playing a hang up tone now. Pretty complicated, right? Well, we did say this was a deep dive. So what is a SIP invite? Let's break one down. Over on the left here, I've got a capture from Wireshark, and you can see it once again, it looks pretty daunting, but it's really not that bad. As with most things, once you understand the lingo, you can make sense of it pretty well. So let's jump into this. Now, for those that haven't seen a Wireshark packet capture before, I'll very quickly let you know Wireshark grabs information off your network and then puts it in a way that's viewable for us humans. There's a bunch of plugins installed in that to then decode the information. One of those is a SIP decoder. So in this case, we can see that Wireshark has decoded all the information and is presenting it for us in text format. So first off, if we have a look at the third line from the top, we can see this is an IPv4 packet with a source address of the source phone, in this case, the source PABX. And then with a destination of the destination PABX. We can see that it's using TCP in this case. SIP supports both TCP and UDP. I'd make the lame joke about UDP, but nobody gets it anyway. We also specify the source and destination ports. So the source can be a random port typically, but the destination is almost always 5060 or 5061. And then we break into the actual SIP packet itself. So this is up here is your layer 3 stuff, if you know your OSI model. A little bit lower down, we're getting into the actual invite. And you can see the first line off the bat is invite SIP equals, and then the telephone number at the destination PBX. Now we'll see that destination phone number, or the phone number I dialed, multiple places in this SIP packet. I'm requesting this number. I need to contact this number using this number here. And it also appears in the to field down the bottom. Now, the reason that these fields appear more than once is because we can do proxying and stuff, but that's outside the scope of this session. We'll also see the caller number, or in this, for example, caller ID. So this is the from number, my mobile phone in this case, trying to call this PBX down here, but we'll see that the same sort of thing, the from number also has an associated IP address next to it. So we can see we have the from, the contact down here, and the contact URI. We also have their associated routes. So these are all the servers the call is going through in that case to get from its endpoint. You can think of a route like this as any SIP-aware router or an SBC. An SBC in this sort of case is very much like an IP router, but instead of routing packets from one place to the other, it's routing phone calls. It's SIP-aware. You'll also see that is part of the invite. We're putting in the destination PBX, or where we believe the destination PBX to be. So for example, my phone or my SBC is going to contact a particular server because it believes that number lives at that server. We're also contacting that endpoint via TCP. Now, further down in the, I can see Martin staring at my screenshot. Further down in the packet, we have the SDP. Now, this is something we've been talking about a fair bit so far. So let's break it down. So if we scroll down in our packet capture, we can see the SDP as highlighted by this line that says Session Description Protocol. Now, it contains a lot of information, but again, as we can see before, we're still calling this number. We're still calling this destination PBX. And we still have our phone as our source IP address, but we have our SDP down the bottom of the packet. As you can see, in this case, the connection information, that IP address is different from the destination IP address. This is the IP address that I'm connecting from. Now, the main reason that this is important is because the PBX and the endpoint don't necessarily need to be the same. This is done because we can bypass media from one endpoint to another. So if I've got one phone calling another, the audio path doesn't have to go through the PBX. So in the SDP, we have a line called the C line, and this is the IP address of the host that is performing the audio, in this case, my phone. We have a codec list, which is the two codecs in this case that we are supporting. We have our codec preference. So this is a list of the real-time protocols that we support with two numbers here, in this case 0 and 101. These two numbers match up to the two codecs in the codec list here, and this is their preference from left to right, being most preferable to least preferable. We have the port, or the port pair, that the media will be coming from. In this case, I can see it's a TCP port and 4861. So this is where I'll be sending you audio from, or I'll be expecting my audio from in regards to your remote PBX. Now, I'll send this to the remote device and it will send me one as well. And using that information, I can establish calling between the two endpoints. Here's the same sort of view, but using a different tool. This is from Ribbon's LX tool. It's the same sort of thing. We can see the text is very similar. It's just presented in a slightly different way. We still have our IP addresses. We'll have our destination phone number and destination PBX. We still have our source phone number and our source PBX. The associated to fields and the SDP. So we don't really get to hang out on this much because it is a live event, but think about it now. Which SIP message contains the SDP? Is it trying, prac, ringing, or invite? We'll move along, but just think about that for later. Stick your answers in the chat if you want to. Otherwise, let's keep going. Had enough time? Cool. The answer was invite. The invite contains the SDP. Would also be in an OK message or a early media 183 message. So we've been talking about SIP quite a lot. What about codecs? Codecs are part of what makes up the SIP standard, right? Well, codecs are a little bit more complicated than that. What they do is kind of in their name. A codec is a coder and decoder. It has the ability to code information and decode information for us. We use them as a standard for transmitting sound over VoIP networks, but it can be used for anything. MP3 is a codec by definition. We encode sound into an MP3 format for those of us old enough to remember MP3. And then that's a way of, we then decode that MP3 so we can listen to it. But codecs define things such as sampling rate. So sampling rate is how often we sample the incoming sound, and we'll get into that in a second. Bit depth. Bit depth is sort of like resolution for sound. The more bits you have, the higher the quality of the sound, generally. How we're compressing that data and how many channels we have. With most voice codecs, we only deal with one channel, but in some meeting cases, Skype for Business particularly, supported 2 channels or stereo sound. And another thing that codecs can define is FEC or forward error correction. So what is sampling rate and resolution? Excuse me, just a moment. So as we all know, or hopefully know, sound is made up of waveforms through the air. I'm talking to you now. My voice box is vibrating the air as I breathe out. That's creating vibrations in the air and creating a pressure wave through the air. That pressure wave is received by your ear, and then your ear, with all its fantastic ear listening bits, turns that into something that you can understand and process with your brain. That's great. Computers don't speak ear listening bits. They speak digital. And so we need some way of converting that from an analog waveform into digital. So the first thing we'll need to do is put a microphone on our computer. And our microphone, all it's doing is grabbing that pressure wave and grabbing it from a real wave in the real world to a sine wave on the computer. So again, we've still got this wave shape on the computer. It's an analog voltage, but the computer again doesn't speak analog. So we need a way to approximate that as closely as we can. So what we do is we divide it into our bit rate. So you can see here's an example of 8-bit bit rate. It's not exactly true. In 8-bit, it would be 255 lines, but I wasn't going to draw all those. 16-bit would support 65,535 different points of resolution here. And then we have our sampling rate. So our bit rate is our y-axis, where it's how strong the signal is, whereas our sampling rate is how often we sample. In this case, 11,000 times a second. So every 11,000th of a second, the computer figures out how strong that signal is, how high it is, and writes it down. And it does that 11,000 times a second. We'll bump up to 22 kilohertz or 22,000 times a second, and we get roughly twice the quality. So as the computer writes these down, you can see it every time it takes a sample, it writes down a little dot to say, at this point in time, this is how much sound there was. At this point in time, this is how much sound there was. And we continue until we capture an approximation of the waveform. So we can then take away the analog signal, and we have a graph of these numbers that the remote computer can then play back and get an approximation of the sound. Now, I could go on about this for hours and about the Shannon-Nyquist theory and stuff, but it would absolutely bore you to tears. If you do want some more information, there is a QR code in the corner for a great video by Technology Connections. He is much more enthusiastic about this than I am. Go and check it out. Okay, so we've talked about codecs, but we understand what they are and what they do, what codecs do we have available to us with direct routing? Well, Microsoft Teams and Direct Route today supports 4 codecs: Silk, G722, G711, and G729. Silk was a codec that was originally written by the Skype team when Skype Consumer was around, and it was groundbreaking for its forward error correction and for ridiculous audio quality over such constrained links. G722 is a relatively high quality codec and is used in different flavors to provide high quality audio. For example, on your mobile phone, when you call another mobile phone, you may notice that you have extremely high audio quality versus when you call a normal landline from your mobile. G711 is a codec we've had around since the ISDN days, and it is literally someone grabbed ISDN and copied and pasted that into a computer. That is exactly G711. It comes in 2 flavors. Realistically, for all intents and purposes, it doesn't matter which flavor you use, but you must use the same flavor in your appliance if you're using it with ISDN. And G729 was a codec that was made in the 90s to deal with dial-up connections and ridiculously low bandwidth. It compresses the audio and sounds terrible, so please don't use it. I don't care what your carrier says, it sounds horrid. Don't. So we're going to go for another quick quiz. Which of these codecs was developed by the Skype team? G722, Silk, Opus, which is something I really didn't cover in the last section, or Saturn? Thought about it? Stuck your answers in the chat? Well, it was actually both Silk and Opus. I didn't really cover that. It was a little bit of a trick question. Silk was the original codec that was written by the Skype team, and when Microsoft acquired Skype, they open sourced Silk and released it as the Opus codec. So plenty of vendors support Opus now and get its benefits from that. And for those playing along at home, Saturn is a codec that's soon to be coming to Teams, and I'm excited to see. All right, so we've talked about SIP, we've talked about codecs. Now let's talk about SBCs. What is an SBC? An SBC is, for all intents and purposes, a router. I know it oversimplifies things, and if any vendors are on the call, they're going to be screaming at their headsets, but it is a very smart voice router. Now, in this case, I've got no particular order or no preference or anything for vendors. I have 2 SBCs in my environment, and I'm using them to route calls between different infrastructure. On the left, I have my SIP carrier. I have a ribbon SBC connecting to a legacy PBX and the SIP carrier, as well as an audio codes SBC connecting to an analog device and Office 365. Again, vendors or capabilities are completely out of this question. They all do the same for what we want. So in this case, I've got a call that's arrived from my SIP carrier. That carrier then sends the call to my SBC. And the SBC looks at its lookup table, and it can look into Active Directory, it can look into a whole bunch of different services. It doesn't really matter, but it makes the decision that this call belongs on my legacy PBX. Now, this stuff is really handy when you're migrating from an on-premise telephony solution into Office 365 or into Microsoft Calling. You can use your SBC to make these decisions for you and send calls into 365. So in this case, I've got another call. It's gone through the ribbon. The ribbon's forwarded it to the audio codes. And in this case, it was a call for the analog device. Okay, cool. Same scenario again, but this time, both the devices have determined it's a call for Office 365. We convert it from unsecure SIP into secure SIP, and then send it across the internet into Office 365. Now, as I said, you don't have to have 2 SBCs. You can have 1, you can have 10. It completely depends on your scenario. If you've got some sort of commercial PBX on site now, you'll probably have an SBC, but you'll need to get a Teams certified SBC in there somewhere. So with Teams, what happens when I make a call in Teams? We saw what happens when I make a call from the outside world. It hits my SBC and then eventually gets to Office 365. Well, what about if a user is making a call from their Teams infrastructure? Now, it's all good. We've seen sessions where you just plug an SBC in and it works, but we know that's not exactly the case. We'll quickly break down this diagram, and it's not too daunting, but understanding how this sort of stuff works can be really helpful in implementing some complex call flows. Some things that people will tell you that Teams doesn't support today, or you can't do that on Skype, because, well, you can. You just have to have an understanding of how voice policies and calling plans work so that you can route calls to different SBCs across the world. So I'm a user in Germany who wants to make a call to this number. Now, the number's already been normalized and everything, so we won't go into that. When the user makes the call, Teams checks to see if there's a voice routing policy for that user. If it does, it then starts comparing the number against the PSTN usages that are available for that routing policy. If we have a match, we send the call to the SBC that matches that PSTN usage. That SBC will then send the call out via your PSTN, and it's considered a successful call by direct routing. If we didn't match any of those calls, those PSTN routers, then we'd hit Microsoft Calling, or if you're in Australia, it would be Telstra Calling for Office 365, or one of Microsoft's partner carriers in other parts of the world. So a user dials a number. They go through voice routing policies to determine if they're allowed to call that number. They go through voice routing policies to normalize the number. The PSTN usages then will find if that user's allowed to dial that number. Perhaps maybe it's a premium service number or an international number. Then once that usage has been applied, it'll go out the relevant voice route. Once it's found that voice route, it'll then go to its associated PSTN gateway in Teams, which is your SBC. The call then flows to your SBC. The SBC then has its own internal routing table, or as we call them in the SBC world, translation table, and then we'll send the call to the carrier. Now, if you had analog infrastructure that you wanted to work, or perhaps SIP extensions in your infrastructure, you would have translation rules, routing policies that capture these numbers and send them to your SBC so that you could then route those directly without having to go out to the PSTN. That's something that I'm not going to cover here, but it is food for thought while you're going into it. All right, I'm getting a little low on time. We've only got a couple of minutes left, but we're in the home stretch. So one of the things with voice policies and routing with voice policies and usage policies and PSTN usages, they all center around a thing called Regex. So Regex is a tool that's used to match and manipulate strings. We use this to validate that the number a user is entering is correct, or it's in the right format, and translating it if we need to. So the most common use for Regex is to turn a 4-digit extension into a full national number. So for example, here in Australia, I might need to dial 648 and translate that into my full national number, which is +61 432 500 648. That's all good and makes sense, but what's Regex really? If we go into these few slides, I've got a very brief breakdown of everything you need to know about Regex, but don't concentrate too hard on it because there are some tools to help you out. We'll get into it. This is, however, something that's useful to understand if you're ever troubleshooting. Regex typically will always start with a caret and finish with a $sign. And no, it's not a pound sign in Europe. I'm sorry, it's still a $sign. If we want to match anything, we use a dot. If we want to match just a digit, we'll use a backslash escapes the next character, and D for digit. If we want to match certain numbers, we enclose them in square braces. We say, I want to match a number between 0 and 7. I can also eliminate the dash here if I want to. We also have pipe, which is a character we use as an OR. So for example, if I want to match the number 123 or 456, then I can say, well, match 123 or 456 in my Regex. We have the backslash character, which is, we use this to escape characters. So for example, E164 numbers by default are in +614 format. Plus is a special character in regex, but we want to actually match it. So we're going to backslash and put plus. And then if I was to use 1 or 1, 2, 3, I'd be matching those strings directly. Curly braces in regex have a slightly different understanding, have a slightly different use to the numbers in square braces. So previously in square braces, I was matching anything in those braces. Now in curly braces, I want to match this many times. So for example, in the top example, I'm only going to match whatever, for example, a digit 9 times, or I'm going to match a digit between 5 and 10 times. I can use an asterisk if I want to match as many times as possible, but it is slightly dangerous. I try and avoid using it if at all possible. You'll see a lot of people writing regex, they'll just put dot star and that matches anything. Great, yeah, it works, but so does any on your firewall. Question mark is usually a better one. Matches either 0 or 1 time, or plus will match at least once. And realistically, don't use it. Because plus is used a lot in numbers in direct routing, it's not really handy. And something you've probably seen so far in the regex that I haven't really covered is normal brackets. And these are capture groups. So let's say I've got brackets around something. I want to capture the information that's in that group and then be able to substitute it. So later on, you can see I've got my $1 or /1. That means I'm going to replace in my output whatever I've got in my first capture group in here, and the $2 will be in my second capture group. Now I know this is a little confusing to begin with, but there are tools to help you. I'm not going to expect you to do this. This is again from my longer session. If we were doing regex to match an Australian number, how would we do that? Here's a few options. If you know the answer, scribble it down in the chat. Otherwise, we'll move on. The answer is A, and we'll quickly break down why that was true. We start with a caret, which is the start of our regex string. We have a backslash to escape the plus. Then we're going to match 6, 1, and then we're going to match a digit 9 times. So Australian numbers start with +6, 1, and then have 9 digits. Then we're going to end the string because there should be nothing else. In the second example, we forgot to put a backslash before the plus, so it doesn't work. In the third example, we use the wrong braces on the 9. So we're going to match the digit. We're going to match +6, 1, then a digit, anything between 0 and 9. And then we're going to match the number 9. That's not going to work. And in this example, we're going to match +6, 1, and then +6, and then 1 infinite times. So yeah, I'd be able to call +6, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That would work fine. Not very useful though. Okay, I am at time, so we're going to have to quickly scoot through these. I hope don't mind if we dig into our Q&A time a little bit. I'm sorry. If you're having troubles understanding regex, there is a great tool over in the right-hand side here, regex101.com. There's plenty of other tools online. They're all free. They're great to use. Check them out. I've been working with regex for nearly 10 years, and I tell you straight up here and now, test your regex. Because it's very easy to get overconfident with your code. I actually recently put out a tweet saying, who made this ridiculously complicated piece of regex, as you can see on the screen now. And it turned out I tagged a person, Ken Lasko, who makes one of these tools that you'll need to use while you're setting all this up. Turns out he wrote it and promptly schooled me on why my regex was wrong, because I didn't test it. It turned out it worked with that one number I tested, but I kind of forgot that, I need to be able to match the number 1000 and the number 2000. It sort of bit me in the backside. But also it's important to understand that there's no right or wrong way to write your regex. So Ken came back and he said, well, here's a slightly better way of writing it. And another person in the community came back and said, well, here's another way to write it, and that's easier to read. I promptly came back and went, well, these two ways would probably work too. And they're all valid ways of matching your regex. Realistically, it just comes down to making it easy to read. So when you're trying to build your regex using regex 101 or Ken's ucdialplans.com. Try and make something that's easy to read, because it will be you troubleshooting it at 2 a.m. in the morning next time when you stuff something up. So keep that in mind. Now, how do we set up routing? I've got an example on screen now, but I would point you over to Damien Margaritis' blog, who has a great step-by-step guide on how to set direct routing up and get it working in your test tenant or get it working with your test SBC. You can grab some free SBCs from both our SBC sponsors, actually. All of our SBC sponsors have free things that you can set up in Azure and have a play with. So check it out. Damien's got a good article on all the PowerShell that you need to get working, and it's literally cut and paste. The other thing you'll need to change is your call patterns, and that's easy because you head over to Ken Lasco's website at ucdialplans.com and fill in what country you'd like calling plans for. Ken's website will spit out all the relevant PowerShell that you need and get the ball rolling. If you want to set a user up for your direct routing, well, in this case, I've got some PowerShell on screen again. I've set them up with a line URI, which is the telephone number that you're going to call them, and their voice policy. So the voice policy is what I'm allowed to or not allowed to call. Again, Damien's blog has some great information on how to set this up. I'm not going to go into too much detail here on that. But I will say, if you are going to start setting all this sort of stuff up, check out a couple of tools by fellow MVP, Melbourne MVP actually, James Cusson. He's written some great tools that make looking at, manipulating and working with all the regex and all the PowerShell to do with setting users up or setting call plans up in Microsoft Teams so much easier. Download these little PowerShell scripts from his website. QR codes are on screen. And connect them to your 365 tenant. Very simple, very easy to manage if you're learning about what's going on before you get too carried away. Anyway, so that's it for me. I do apologise for going a little bit over, but we will have a quick shout out to our sponsors, and also thank you for you guys turning up to an event like this. Like I said, everyone was sort of in a bit of a difficult spot in the world right now, so it's great to see everybody coming together and getting everything on. So as I said, I'd like to give a quick thank you to our sponsor, Regex. No, that's YouTube. No, really, our sponsors, all on screen now. They're all a big part of the Teams universe for both voice and productivity. Go check them out. Help these guys out. Help the team out that's let you have this conference and have made it happen today. One of the things I will ask anyone that has attended mine or any session is to go and have a look at the survey. Give some feedback. Give some feedback to your favorite presenter. Let them know that the session was good. Was it too technical? Was it too hard? Too fast? Give us feedback. This is the only way we can improve. So check out your survey. Otherwise, I'll be in the breakout session after this. So if you've got any questions or anything, I'll take them now. We'll go for a couple of minutes and then head to the breakout. So yeah, that's it.
Okay, we have got a couple of questions, James. Are all codecs supported in all scenarios, meetings, P2P calls, call queues, and auto attendance?
Oh, good questions. Okay. So this session is purely about direct route. There are a bunch of different ways that codecs work in different sessions, in different scenarios. There is actually a massive list of codecs that Teams uses, but these 4 codecs were the ones that are used by direct route. So if you were to send a call at G711 into Office 365 and that had to be transcoded into something else to work with call queues, for example, like in Skype for Business and G722, don't get me started. And that is the responsibility of Microsoft to transcode, and that's to change it from whatever format to whatever format. So everything in Teams is natively speaking Silk or Satin, but it's Microsoft's SBC. They have an SBC in Office 365. They have hundreds of them. Its job will then be to convert whatever you're speaking into whatever they understand. Part of your invite is saying what I support, and the other person has to support that as well, or the call will fail. Or someone in the middle has to transcode.
Okay, so we got some feedback. The UDP joke, somebody lolled at that. Another one from Jan. When troubleshooting an E2E call with Silk Coder, do you have a tip to listen to the voice streams? Wireshark can't play this codec like it can with G711.
Ooh, I can't look. Look. My experience, I've not actually experienced that, but first off, props to actually getting that in a decrypted format. So Teams is encrypted by default. So obviously you've imported certificates into Wireshark, which I know is a bit of a pain.
Yeah, so it has in brackets on the provider side where it is unencrypted.
Yeah, so if it's going to the provider, I'm surprised that they support Silk unencrypted. But long and short of it, you may be able to manipulate the invite to say Opus and then decode it that way. But yeah, I couldn't really give any formal comment on that. I've not tried it. Sorry.
That's all right. Feedback, great session, James. Renee loved the joke at the end. Some feedback on Regex. Dot star works too, which I think you covered.
Dot star really is horrible and should be shot.
Not really a question, just want to say really good session. That's all the questions that we've got in there.
Awesome.
So thank you very much for that, James. So if you want to talk with James and meet up with him in the breakout after, the URL's on there, and I put the URLs and announcement in the live.
I've got Tim Tams. I'll share. I promise.
Thank you very much, James. I'll let you just finish the session, but that's it.
No, that's it. Thank you from me and from all of us here at Commsverse. It's been a pleasure. I love doing stuff like this. So yeah, thank you.